So, for the first law of thermodynamics problem, calculate the heat transfer, the work done, the change of enthalpy, and the change of internal energy for the vaporization of 1 gram of water at 100 degrees Celsius and 1 atm pressure. The change of the evaporation of the enthalpy of the water is 2,260 joules per gram. Assume ideal gas behavior. The density of the water at 100 degrees Celsius is 0.9588 gram per centimeter cube. So, given that the water is 1 gram and is at 100 degrees Celsius, also equal to 373 Kelvin, 1 atm, and the change of the vaporization of the internal, the enthalpy is of the water is equal to 2,260 joules per gram. Density is at 100 degrees Celsius is equal to 9.9588 gram per centimeter cube. Now the required here is the heat transfer, the work done, the change of the enthalpy, and the change of the internal energy. Now we're gonna solve for the Q first, the heat transfer. It is very straightforward, which is also equal to 1 gram of the water times the evaporation of the enthalpy of the water, which is also equal to joules. So we already solved for Q. Now next, I'm gonna state the first law of thermodynamics equation, which is also equal to the change of the internal energy is equal to the heat transfer plus the work done. Now the work done here is by the system, so it's negative sign. So the change of the internal energy, the work done here also equal to the change of the pressure times the volume. Now at constant pressure, only the volume is the variable here. So this also can be written like this. Now this part is also equal to the change of the enthalpy, because the change of enthalpy is equal to the change of internal energy plus the work done, and also equal to the heat transfer. So we can say that the change of enthalpy is simply the heat transfer, which is 2,260 joules. So this is done. Next is the work done. Work done is equal to the work done by the system. Now pressure here is given. The volume here, we're gonna solve for the volume. So the volume here is equal to, gonna use for the ideal gas equation, which is nRT over P. Now the mole of the water is already solved for it, so we just simply plug in. That's simple. mole of water times the gas constant times the temperature, 100 degrees Celsius, which also equal to 373 Kelvin, all over the pressure is given. Now we already solve for the volume, which is equal to 1.70 liter. Now we plug it in the equation. Now pressure here is given, so it is 1 atm. The volume here is 1.70 liter. Now we're gonna convert the liter here into joules. So we're gonna times it with 101.32 joules per 1 liter ATM. So this cancel out. We'll only have 172 joules of work done by the system. Now, work done is solved. Now, we're going to solve for the change of internal energy. As I said earlier, change of internal energy is equal to the heat transfer minus the work done. We are to solve for the heat transfer, which is this. We also already solved for the work done. It is this. So just plug it in. Q is 2060. 172 joules is equal to 2088 joules. Okay. Thank you.